So in this video, we're going to talk about logarithmic models. The last model we have, logarithmic model is written in standard form here. We have logarithm base b, some value x, y. That's a standard form of the logarithmic model. Now, the good thing, it might look foreign, but the good thing about this is it's all based upon exponent notation. So we're going to write three statements that say the same thing. Let me start with exponential notation. So what we have is what you would learn sixth grade. 6 squared is 36. Now, we all know that. Let's take a look at writing that out from exponential to logarithmic. The log, my base is 6. 36, my exponent 2. That by going sort of counterclockwise around the logarithmic notation, so we have an idea of what's going on with the expression from exponential notation that we're familiar with. Now, let's take a look at writing this out as an English equivalent. So what this is logarithm (36) base 6 is 2. Three ways of expressing the same thing. Here's the first way you learned it. Here's the logarithmic way of expressing that expression equivalent. Let's take a look at another one. 2 raised to the 5th power is 32. Writing that out as a logarithmic equivalent. There's my base 2. There's my 32. There is my 5. 2 raised to the 5th power is 32. There it is written as logarithmic equivalent. In English, the logarithm (32) base 2 is 5. Again, three different ways of expressing the same notation, exponent, logarithm, and sentence. The general shape of a logarithmic model like this. Here we would have y log of b x. How that would look written out as graph. All of these graphs go up, flatten out like that. It's got a lot of play, flatten the curve. That's what a logarithm is. Now, let's take a look at some examples of converting from exponent to logarithm, logarithm to exponent. I have 5 raised to the 3rd is 125. The logarithm, base 5, 125, 3. Counterclockwise rotation around this logarithmic expression gets us back to the exponent equivalent. Base 3, logarithm, 4, 81. That one's easier. 3 raised to the 4th power, 81. This next one, if there's no base, there's an understood 10. 10 is our standard base. 10 raised to the 2nd power is 100. This next one, all kinds of things going on, but you follow the pattern. Here's my base, 6. My value is 1 over 36. My exponent is negative 2. And then the last one, Here's my base 10. My value is 1, and that's equal 0. 10 raised to the 0 power 1. On the next video, we're going to come back and look some examples of using your calculator and application